We are a builder in terms of electronics. We are a builder in terms of circuitry. So we have a lot of opportunities to engineer things right. How is it better for the consumer, first of all, because it's going in their home? How is it better for the installer? What have we done to take care of their concerns?
Hi, I'm Paul Kreischer. Welcome to Heart of a Building. This show dives into the building designs that are cutting edge, really pushing the envelope of sustainable living. Along the way, we'll also explore the motivation from the people involved in these great projects. In short, their why. Today, we're in charming Old Town Fort Collins, Colorado, packed full of shops, parks, restaurants, and breweries. And in the center of it all, LAvenir. Townhouse-style condo homes focused on the health of their residents, as well as the health of the planet. I'm passionate and spiritually called to share these stories. The primary reason is buildings and their construction are the source of nearly 40% of the emissions that are exacerbating climate change. Also, this story showcases electrically powered transport, which accounts for about 17% of total U.S. greenhouse gas emissions, coming from light-duty vehicles such as you're in my car. So now, let's go enjoy and take a look at LAvenir. Speaking of transportation, LAvenir has a shared electric car that is part of the HOA. Do you know how much energy is required and what it costs to charge it? Find out later in our program. LAvenir was designed by Davis & Davis Architects and built by Phil Green Construction. These are true net zero homes, which basically means the amount of energy used is about equal to the amount of renewable energy produced in each condo. I love the nerdy technical details of how the designers and builders accomplish this difficult task. But first, what's the motivation? To find out, I'm talking with a team of people who helped bring this project to life, starting with the architects who owned and moved into one of the units, Lori and Bob Davis. I thank you both, for sharing the space and allowing it to be shared with our Heart of a Building audience. I would love to hear the reasons why. Why did you come together to make this project what it is?
We came to Fort Collins from San Diego 10 years ago, and we loved the town was so walkable and bikeable, and the downtown is just such a nice, sweet, gentle urban place. Right. And so our desire to build a net zero energy home turned into, hey, let's do an urban net zero energy townhome project so that we can spread it out. We just felt passionate about doing something that we believe in and that is for the planet. It's really important that architects and developers and contractors that have the knowledge and the ability to do these things really put their money where their mouth is and say, hey, I can show you how to do this.
And we've already done 4 projects that were various LEED certifications already. So we knew how much work it would take and how long it would take.
The Institute for the Built Environment, Colorado State University's institute, has been around now 27 years. Can you tell me a bit about what the Institute did to be involved with the design as well as the promotion of this great project?
Hearing about this project and realizing their great ambition, we don't get to talk about positive. We talk about being less bad. Mm-hmm. This one is good. It's actually doing good for the planet.
I mean, you guys have amazing credits already connected to this, awards that you've received connected to this project that have to do with LEED, earning LEED Platinum, and looking at, I guess for a first time, a LEED positive scenario.
So first of all, LEED stands for Leadership in Energy and Environmental Design. There's 4 levels: certified, silver, gold, and platinum. Obviously platinum at the top, and this LAvenir soared over platinum.
Okay.
And Katie and I got to help in the documentation of all of the various aspects: the site work, the energy, the water, the materials, the indoor air quality, and other innovations that were part of this.
utility was very much involved in helping with design guidance process and just helping with general assistance in making this project a reality.
Yeah, I mean, Fort Collins as a community has had some very ambitious climate and energy goals for a long time, and has recognized the importance of buildings as a linchpin to that performance. Specific to the program you mentioned, the Integrated Design Assistance Program, it really recognizes that it doesn't necessarily cost more to build high-performance buildings like LAvenir.
People think it does.
But it does cost more to design them. It takes a little bit extra effort, a little bit extra time for the design team, and that IDAP program, as we call it, is really designed to help offset that cost a little bit and sort of encourage that design process, that integrated design process.
In Fort Collins, the community recognized a long time ago that the most challenging projects oftentimes are the ones that fall short of the money to get them across the finish line. Our organization was set up to assist with that, and with Bob and Lori's project, we got involved using tax increment financing. We focused the investment. It was a total of $76,000, and it's derived from the fact that their property was a vacant lot to begin with, and when they constructed the building, it lifts the value of the property. That's the incremental tax, and our organization receives that. We focus that on the facades and the photovoltaic rooftop solar system.
We happened to find this vacant lot, tiny orphan vacant lot, 4,600 square feet. A standard single-family residential lot, or a conforming, I should say, is 5,000 square feet. So this is smaller than a single-family residential lot.
We have 4 units.
4
here.
units.
Right.
We also, it had 2 underground storage tanks for petroleum. So it had been a gas station, so it was
That
a
was not fun,
brownfield
right.
site. We had to mitigate that, environmental hazard. We received a grant from the Colorado Petroleum Mitigation Fund. I believe that's what it's called.
It's a great fund.
But they helped us to pay for this,
To get the old tanks
to get
out.
the old tanks and
that had been
to certify
leaking.
that
They were
had
not
not
leaking
leaking.
anymore.
Not leaking, okay.
Thank goodness they were
but
not
there's still
leaking.
old
We lucked
storage
out there.
tanks. Yeah,
Yes.
okay.
Because the lot was so small, we had to ask for several modifications to the standard of the land use code.
I think the thing that impressed me the most and that I did take away from this is the amount of communication and integration with the city that had to happen, and how they really had to continually work with them as a partner to develop a lot of the ideas that they had and see them come to fruition, chiefly the parking and the
electric car.
electric car.
Okay.
Part of the trick here is that we have a car share in the back of our space.
Electric
So
car,
it
right.
immediately takes the car in your space out of into a totally different thinking sphere, because everybody's car is in a garage that's 500 feet away. So when we park
less.
our car in there, first time we did it, we didn't even get in the darn thing for 5 weeks.
Right, because you're using the electric car.
Right, because the
walking.
electric car's right
Or the
here. It's
electric
far-
bike that you have, or
We
the
have
bikes
electric
that you have.
cargo bike as well that's shared. We share it through a calendar system that we all have access to, so the car and the bike are all on that calendar. So we
is
know
great.
who's got it and
And
how long they
thus far
have
there
it.
hasn't been any fights?
No.
People been good?
No.
You've been working together with this?
No, the garage
We call
floor,
it flex space.
we designed it to be a flex space
Right.
because we didn't know, would people buy a place that they didn't have a car
In their house.
right inside their house?
The people that have purchased here, the other 3 people, because you're living in this one, you designed it and built it, and this is where you're living. The other 3 all chose to use it as flex space,
Yes.
right? Not use it for a
No,
garage.
no one
They
for a
didn't want it
garage.
for that. While we're here, part of what we're standing on is, it looks like a normal concrete floor, but this is actually part of thermal storage for your building.
This is a 30-foot deep space.
Right.
20 feet to, which is a car dimension, 20 feet from the south to north is slab on grade.
Right.
And it has radiant tubes in that so that the slab is heated. This portion in the front, the tent 10 feet in the front, is over our utility room where our special, game changer equipment is.
In this specific project, this is now a net zero energy performing building after they've been in here for just over a year. And a big part of the reason for it is because of the choices made to put in this ground source heat pump, heating and cooling equipment. How do the efficiencies of this system compare to more conventional, electric, heating cooling systems in the industry?
Yeah, significantly more efficient. So for example, if you were going to compare this system to a gas furnace, a gas furnace, the most efficient that you can buy on the market is about 95%. So what that means is for every dollar of gas that you buy, you get 95 cents worth of heat out of it.
Right.
With geothermal, you have what's called a COP, or a coefficient of performance, when typical value for that is a 4. So what that means is that for every dollar of electricity that you buy to run the geothermal system, you get $4 worth of heat out of it. So they're 400% efficient as opposed to 95%.
Right.
We decided to go with the water-to-water unit. And we had challenges on this building, especially getting ductwork everywhere. We had to come up with a solution where we can, get heating and cooling everywhere, but we didn't have a lot of room for soffits and things like that. So we do the water-to-water unit, and then there's actually 2 air handlers, one on each floor.
Air handlers, just for people who know, so we won't nerd too much on this. Air handlers, think of it as like your furnace. I mean, that's what most people think of it as. It's where the fan is in there. And in this case, there's not natural gas burning in there. There's water with glycol in it coming up from the ground that runs through a little heat exchanger to do that.
And this unit makes either hot water or cold water and sends it to those units, and that's what conditions that space.
Right.
So that's that was a challenging part, to figure out how to make all that work together.
Yeah.
But it all worked out great, and we got a nice, comfortable house and a comfortable system.
What'd you put on this?
Yeah, with this unique project, we wanted to select the highest efficient panels available, and we selected 375 watts.
Okay, so each panel is rated at 375 watts of capacity as far as what it can generate, which is great, so yeah.
That's correct, and it's amazing. 5 years ago, a similar size panel would have been only 300 watts.
Right.
And 10 years ago, that would have been like 200 watts or less.
Right. Now, in the case of this system, the inverters, as I understand it, make it where if one panel goes out, the system doesn't go down. Inverters, so people know, is taking DC electricity, because that's what's generated. And in our homes, in our buildings, we have AC electricity. So it's basically inverting that to become AC electricity. Otherwise, we'd burn up TVs and computers and things inside. So we got to have that inverter. But yeah, tell me how that works.
So solar panels used to be just in a string. And so if one panel were to go out in that string, it'd be like Christmas tree lights, where the whole string were to go down, your panels wouldn't be producing.
Right.
Similar if it was shaded. But now the industry has invented little microcontrollers that optimize the production of each panel. So we installed optimizers on each panel. So if one panel were to go down or shaded, or for whatever reason, the whole array would be producing as normal.
Another really amazing thing about this project is that they actually have battery backup in Bob and Lori's unit. So how does that work with the solar PV system? Is that integrated, or do they work separately, or how does that work?
Yeah, so the solar and the batteries are DC coupled, so meaning they're both tied into the inverter before it's converted to alternating current.
Okay.
So the solar can feed directly into the batteries during the mornings and charge them up for the whole day. And what's unique about Fort Collins is they have time of day rates. So meaning energy's cheaper during the mornings and daytime versus the evenings, but since you're able to charge it up in the morning, you can discharge it during the peak hours and get more for that solar power that you produce.
I want to check out the rest of the house, but before we leave here, I just want to say, you did such a beautiful job with this. What could have been a garage door, this beautiful sliding patio door that allows the space on a beautiful day like we have today to just be flowing from inside to outside, being use of a larger patio area to make the space that some people might say, well, it's a little small. Well, you got all this beautiful space back here to access, which is just outstanding. And the way you design the overhangs for your windows on the south side. allowing for this to be shaded. I mean, we're near middle of the day, and you've got great shade on the patio, let alone in the house down here. But in the wintertime, the sun comes in to about that first expansion joint by the bookshelves. So it's like bringing in free heat for you to help warm this home, which
which is
was
awesome.
beautiful.
It's our dog Finn's favorite place to lay in the winter because
He gets warmed up.
It gets warmed up.
Right. Bob, you had another area you wanted to point
I
out?
just wanted to point out that this building is designed to actually add an elevator later on if somebody wants to do that. That goes because it goes from the basement all the way to the 3rd floor, and that elevator would be right in this notch.
Take me on a tour of the rest of the place.
Let's go on a tour.
Okay. Wow, the daylighting in here is amazing. How you've brought in natural light to make it where the staircase, you can see up and down it, no problem. No lights really having to be on in here. This space, I mean, I could perform surgery if I knew how to do it. I mean, it's like...
Probably the #1 thing is having the 10-foot-2 ceilings.
Okay.
And the large French windows and the clear story above.
Right.
It just makes the light that much more bounce off the ceiling.
We limited the number of windows on the west and the east.
Right.
And we capitalized on the big windows on the south and the north because that's where you get your best bang for your buck. This particular window on the 2nd floor, which is our living floor, we wanted to be French windows because we wanted the connection to the outside.
Do you know some of the performance characteristics of these windows?
Yes.
Okay.
So the SHGH is the,
So that's the
solar heat gain coefficient.
What that's telling us is that how much of the sun's heat that strikes the window is actually passing through the window.
You want to have a good SHGH so that in the winter you get sunlight and it warms it up, but you also want to be able to keep the heat in. So that's where the U value comes into play. And that U value, what we've tried to achieve is between 0.22 and 0.25.
That's great.
And a standard window, like by energy code, 0.35 is required. So we're significantly better than that.
You know, for people viewing, the U value side is the inverse of R value that some of you, more of you may know about from like insulation. So when she says like a 0.25 to a 0.22, 0.25 means it's an R4 window. 0.22 is about R4.3, 4.5,
basically.
something in that range. Yeah.
Yes.
So it's definitely, Energy Star is requiring like 0.33 to 0.30, so it's a big improvement and gave you the other performance details, the ability to have these windows open the way you want. But one thing I'm noticing, because we've been here today, we've had these windows open, and it's 92 degrees, and we're in Fort Collins, so I guess we should probably close those windows.
Time to close the windows.
Time to close the
Sorry that we let some of your, we let too much heat in today.
The cool air rushing out?
Exactly.
We do have to balance that. So we night flush. We open windows and allow the cool air to go through from north to south. And in the morning, we close them before we go to bed. And in the morning, we open it up again.
Yeah.
And
we also
flushes
close
out.
these windows at this time of the day because you can see what's going on.
Right.
Heat gains right there. That's why we have floor-to-ceiling drapes.
Net zero energy homes thrive because of having great insulation, great air sealing. I'd love to hear from both of you, but Lori, I know it was a lot of your thought process and design process that finalized this. So can you describe for us like the walls and the ceiling and the floor and give us some details?
I think the wall is probably the most important part because that's the most surface area of the building. And we did a double insulated system. So we started from the inside to the outside. We have a 6-inch stud wall that has blown-in fiberglass insulation. Then we have the half-inch of the WRB, which is the weather-resistant barrier, and that gets taped at the seams. On top of that, the next layer is 3 inches of rock wool insulation, which is an inert material that does not carry mold.
It's spun rock.
So we have that 3 inches of insulation outside.
Patagonia jacket.
Yeah, our Patagonia jacket.
That's what it's like, yeah.
And then we have the rails that hold the terracotta, which is quite heavy, as you imagine. Terracotta is essentially brick that's extruded.
So you've got a great wall. What's that R value of that?
The R value is 30 to 33.
Right.
So-
And typical code in Colorado for new construction is more like an R19. What did you do in the ceilings here?
So in the ceilings, we have some spray foam at the underside of deck, and then we have, again, blown in a foot of blown in fiberglass.
So in the ceiling, is it about an R49 or R50?
It's R50.
50, yeah. So that's great. And then down below on the ground level, the flex space floor underneath there, you have radiant floor heat, and it's common to put in insulation there, but still, what'd you guys do there?
Well, remember it's on slab on grade.
Right.
So underneath that slab
Is a waterproof membrane.
Yep.
Well, first gravel, waterproof membrane, and then the 4 inches of concrete.
So on the exterior of the basement walls, we have, I think it's 2 inches
Yeah,
of,
I think it's 3 inches of rigid.
yeah, it's funny, it's been so long, I'd have
I
to
don't
look back
remember.
at pictures to know.
It's blue.
Okay, if we make it airtight, super insulated, what are we doing to the indoor air quality?
Right.
So you started to touch on
It's
it.
on the
so
ERV.
Yes, I'd love to hear
which
about
an
that.
ERV is an energy recovery ventilator.
Right.
And essentially, the ERV is using the process of enthalpy.
Yep.
Like, that's hard for me to say,
It's a tough
enthalpy. By taking the stale air that's coming from inside and pushing it outside. So say stale, warm air going outside, cool air coming inside. They cross in the middle so that they exchange the temperature so that the cold air coming in is not just cold air to refresh, it's through that process of enthalpy, it's warmed.
Yeah.
Or vice versa.
Or vice versa, this time they would be
Yeah,
cooled.
right.
Yeah. You got a beautiful deck in the back.
Yeah, and I'm growing tomatoes. First in my life, I have like tomato bushes. There's only 2 of them, but they're gigantic. So it's got to be because the orientation, they're on the deck.
The
and
perfect orientation.
Yes.
We've been spending much of the time on the second floor and in the flex space down on the ground floor. You have a beautiful third floor. So what are some of the highlights you'd like to chat about what's going on up there?
Well, probably the number one thing is that we have a nice sized skylight at the top of the stairs, which really gives light to this glass right here so that the light goes at some times of the day all the way to the stairs at the very bottom.
What parts of this make you the most proud?
We got it done. And we paid the bank.
I'm going to be a little bit more nerdy than that. I think what I'm most proud of is 3 things. The building produces its own energy with the sun and the earth. The building provides for a lifestyle that's flexible. And the last thing is that it promotes a walkable, bikeable lifestyle with the shared car. Those 3 Ps are the ones that I'm most proud of.
Are you planning to do this again? Because I know you want to inspire others to do it, but are you going to
We do.
do it?
We do,
Okay.
but not as a developer.
We asked at the beginning of the show how much energy is required to charge the HOA's electric car. It's approximately 32 kilowatt hours. That would cost $3.85 at peak demand. These folks, however, being very wise, are charging it off-peak. And it's only costing them $1.92 to charge the car to go 160 miles. The same 160 miles in a typical combustion engine car will cost you $25.25 in gasoline. Wow, what a savings. Beautiful, healthy, sustainable, a livable work of art. My thanks to Bob and Lori Davis for letting us explore their beautiful design, and to everyone else on their team for sharing their stories behind these amazing buildings, the homes of tomorrow being built today. I love that Lori and Bob are committed to designing and seeing built more projects like this for an even larger section of the home buying audience, even if they're not the developer on the next project. We look forward to staying in touch with them and seeing what great projects they produce next. I deeply hope that as you watch these compelling stories and learn more about these inspired buildings, as well as alternative transportation, that you too will see we have the knowledge and technology to make our buildings and travel come into full harmony with nature. we no longer need to have emissions coming from their operation. Think about asking for these types of buildings and vehicles powered by clean energy when you're ready to buy. And if you're in the industry, I hope you'll require these specifications when you design, build, develop both new and remodeled homes and buildings in the years to come. Thanks for joining us, and we'll see you next time.